Jai Hind everyone. So our next lecture of cryptography and network security is about the secure electronic transaction. As the name suggests, you can see it consists of three things. First one is secure, means to keep something safe and secure. Second one is electronic, means digital. Transaction is something which we are performing, the transfers, the information transfer, or some of the monetary terms, financial term transactions and transfers, all comes under this transaction term. So after combining these three terms, secure electronic transaction, we are going to talk about our day-to-day transactions which we are performing on our open network digitally, how we can keep them secure. Because as the usage of this open network has increased, the digitization has increased, side by side you can see the forgery part, the security part also plays a very important role. So how so means which particular type of technique or technology we are going to use to keep our information secure is very important, and it also plays a very important role just to keep our things secure. So we are going to talk about the secure electronic transaction in this lecture. First of all is credit cards on the internet. Problem is communicate credit card and purchasing data securely to gain the customer trust, authentication of the buyers and merchant, and confidential transmissions. System vary by type of public key encryption, type of symmetric encryption, message digest algorithm, number of parties having private keys, number of parties having certificates. So these are various systems which are varying depending upon which particular type of features they will provide. So it is a credit card on internet. So these are some of the credit card protocols. First one is SSL. This SSL stands for Secure Socket Layer. First, or one or two parties have the private keys in it. TLS, it is the Transport Layer Security. It is a IETF version of SSL. Next one is SEPP, that is Secure Encryption Payment Protocol. Under this particular head, we have the MasterCard, IBM, Netscape, etc. This STT is the Secure Transaction Technology, consists of the Visa and Microsoft. Last one is the Secure Electronic Transaction, which consists of MasterCard, Visa, all parties have the certificates. So this is the absolute. Now, this is very slow acceptance, but yes, we are accepting now. So what this secure electronic transaction means? It is developed by Visa and MasterCard, designed to protect the credit cards, transactions, confidentiality, all messages encrypted. Trust, all parties must have the digital signatures or digital certificates, you can say, and privacy says that information made available only when and where it is necessary. So these are the three important aspects: confidentiality, trust, and privacy. This is a diagram which shows that whosoever can be the part of this SET system. First one is the card holder. The person who has that card, by using that card, he or she is going to perform the transaction electronically. This is the card holder. Through internet, this card holder is going to access the merchant through an internet. This merchant and the payment gateway will be there, and in between again the internet is there. So you can see in this diagram, whatsoever entities are available, all the entities are attached or connected with each other through this internet. Cardholder, merchant, payment gateway, issuer, acquirer, and certificate authority. 1, 2, 3, 4, 5, 6. 6 entities are available in this complete SET system, and each and every entity is attached to the another entity using the network, the internet, you can say. So card holder consists of card, having the card, merchant by which you are going to perform it. This is the payment gateway which is you are going to use for performing your payments. Certificate authority will provide the certificates to acquirer and issuer. The SET business requirements. It provides the confidentiality of payment and ordering information, ensure the integrity of all transmitted data, provide the authentication that a card holder is a legitimate user of a credit card account, provide authentication that a merchant can accept the credit card transactions through its relationship with a financial institute. So these are the basic necessary business requirements. If we are setting up the secure electronic transaction system, then all these points are important business SET requirements. Some more SET requirements are: ensure the use of the best security practices and system design techniques to protect all legitimate parties in an electronic commerce transaction. Create a protocol that neither depends on transport security mechanisms nor prevents their use. Facilitate and encourage the interoperability among software and network providers. Now let's talk about the actual secure electronic transactions. First point is, the customer browses and decides to purchase what he wants to purchase. Then SET sends order and payment information. The customer first of all decides what he wants to purchase online. Then he sends the order and payment information to the merchant. The seller. Then merchant forwards the payment information to the bank. You can see over here, it is sending the payment information to the bank. This is the merchant's bank. Then bank checks with the issuer for the payment authorization. Once it is sent, the issuer authorizes the payments. Then it will again send back, the bank authorizes the payment. Once bank authorizes the payment, then the merchant completes the order and merchant captures the transaction, and finally the issuer sends the credit card bill to the customer. So like this, a complete SET transaction is done securely, in which we have a customer. These are the following entities available in between: customer, the merchant, merchant's bank, and the customer's bank. So the customer opens an account with the card issuer. It may be a MasterCard, Visa card, etc. The customer receives a X.509 version 3 certificate signed by a bank. A merchant who accepts a certain brand of card must process 2 X.509 version 3 certificates, one for signing and one for key exchange. The customer places an order for a product or service with the merchant, and the merchant sends a copy of a certificate of its certificates for verification. So whatever we have talked about in this diagram, the actual transmission of information from one point to another, you can say this is the step-by-step procedure for SET transaction. It is explained over here that how the actual in between which particular mechanism is used for setting up this SET securely. SET transactions in which the customer sends order and payment information to the merchant, which we have already seen in the diagram. The merchant requests the payment authorization from the payment gateway prior to shipment. The merchant confirms the order to the customer. The merchant provides the goods or services to the customer, and the merchant requests payment for the payment gateway. Key technologies which are used, which are working behind this secure electronic transaction are confidentiality of information, in which DES is used. DES is the data encryption standard. Entity of data, RSA, digital signatures with SHA-1 and hash code are used. So this RSA is Rivest-Shamir-Edelman algorithm, and SHA-1 is the secure hash algorithm with the hash codes, which uses the hash codes basically. So DES is for confidentiality of the information. Integrity is maintained with the help of RSA and SHA-1 hash codes. The cardholder account authentication is done with the help of X.509 version 3 digital certificates with RSA signatures. Merchant authentication is done again with the X.509 version 3 digital certificates with RSA signatures. And privacy is, it is a separation of order and payment information using the dual signatures. So you can talk about the confidentiality, integrity, the authentication, and privacy part. These are the key technologies used for the establishment of a secure electronic transaction. Next is dual signature. Links the two messages securely but allows only one party to read each. Message 1, message 2. Two messages are there. In between you can see the hash 1 and 2 with SHA is written for both these things. Here we have two digest 1 and digest 2, means message digest codes we have. So you can say concatenate the digest together, they are attaching them together. Hash with SHA to create the new digest is there. Then private key is there, which is working for the encrypt the new digest with these signer's private key, and finally produces a dual signature. So you can see the two messages are there, message 1 and 2. Then again hash is there with the SHA 1 and 2. Two digests are there, 1 and 2, and they are concatenated together. New digest is generated, and using with the help of a private key, the encryption of new digest with the signer's private key is done. It will produce the final dual signature. So the concept is link two messages intended for two different receivers. Order information, that is the customer to merchant. Payment information, that is customer to bank. Goal is limit the information to A need to know the basis. Merchant does not need credit card number. Bank does not need details of customer order. Afford the customer extra protection in terms of privacy by keeping these items separate. This link is needed to prove that payment is intended for this order and not some other one. Why dual signatures are used? You can suppose that customers send the merchant two messages, that is, first one is the signed order information and second is signed payment information. Then the merchant passes the payment information to the bank. If the merchant can capture the another order information from this customer, the merchant could claim this order goes with the payment information rather than the original. So here the dual signature operations. This is the PI. It is attached with the hash PIMD. Concatenated hash, it will produce it, and finally it is showing you the dual signature with the combination of these two, as we have seen over here. This is OI, the signed order information. PI is signed payment information. So PI and OI are going to be concatenated like this, and finally we are having a combination of these two named as dual signature. The operation for dual signature is as follows: takes the hash SHA1 of the payment and order information. These two hash values are concatenated, combined together, that is HPI and HOI, and then the result is hashed. Customer encrypts the final hash with the private key, creating the dual signature, and finally this is the signature, dual signature. You can see the hash of these two attached together and hashed again, and finally they are using a key. DS verification by merchant. The merchant has the public key of the customer obtained from the customer's certificate. Now the merchant can compute two values, and finally it should be equal. The DS verification by bank. The bank is in possesses of DS, dual signature, and PI, that is the payment information. The message digest for OI, the order information, and the customer's public key, then the bank can compute the following. This is somewhat like this. That hash of PI is attached with it, and finally it is resulting for the dual signatures. As shown here, the dual signatures. In the same ways, here we have the dual signature DS. So what did we accomplish? The merchant has received the OI and verified the signature. The bank has received the PI and verified the signature, and the customer has linked the OI and PI and can prove the linkage. These are some of the SET supported transactions: credit card holder registration, the merchant registration, purchase request, payment authorization, payment capture, certificate query, purchase inquiry. These are the important things. Purchase notification, sale transaction, authorization reversal, capture reversal, and credit reversal. Purchase request is the browsing, settling, and ordering is done. Purchasing involves 4 messages: initiate message, initiate response, purchase request, and purchase response. So initiate request and initiate response is the starting one, and purchase request and purchase response shows that how you are going to place an order and purchase it. Basic requirements are: cardholder must have the copy of the certificates for merchant and payment gateway. Customer requests the certificates in the initiate request message to merchant, brand of credit card, ID assigned to this request response pair by customer, and nonce. The customer request, that is the initiate response, consists of the merchant generates a response, signs with the private secret signature key, include customer nonce, include merchant nonce, returned in next message, and transaction ID for purchase transaction. In addition, merchant signature certificate will be there, payment gateways, key exchange certificates will take place. Purchase request or you can say purchase response, how it works: the cardholder verifies the two certificates using their certificate authorities, CAs, and creates the OI and PI, that is the order information and purchase information. Message includes the purchase related information, order related information, and cardholder certificates. So this is the purchase request. You can see the cardholder generates a one-time symmetric encryption key, KS, so after zooming, it is very much clear. You can easily see PI is there, dual signature is there, OIMD is there, they are attached, E is there, request message has been received. So it is received by the merchant, passed on by the merchant to the payment gateway, and certain keys are there in between. to perform the encryption part, and these are the abbreviations which we have used in this diagram. So this is how the merchant verifies the purchase request. When the merchant receives the purchase request message, it performs the following actions: verify the cardholder certificates by means of its CA signatures, verifies the dual signature using the customer's public key signature. Merchant verification. The processes the order and forwards the payment information to the payment gateway for authorization, sends a purchase response to the cardholder. So again, this is a diagram similar to that, but it is showing you the merchant verification. Previous one was the purchase request. This one is the merchant verification. It works somehow in the similar part, but previously we are talking about the left hand side. Here we are having the request message, and now we are talking about the right hand side where the comparison will take place after decryption of these two. Purchase response message, message that acknowledges the order and references the corresponding transaction number. Block is signed by the merchant using its private key. Block and signature are sent to customer along with the merchant signature certificate, and upon reception verifies the merchant certificate, verifies the signature on response block and takes the appropriate action. So the payment processes are, the payment process is broken down into two steps: the payment authorization and payment capture. So the payment authorization is nothing. The merchant sends an authorization request message to the payment gateway, consists of the following. That is the purchase related information, that is PI, dual signature, the OI message digest, and the digital envelope. Authorization related information and certificates are there. Payment authorization. Authorization related informations are there, that is transaction ID signed with the merchant's private key and encrypted with the one-time session key, somewhat like this. And certificates consist of the cardholder signature key certificate, merchant signature key certificate, merchant's key exchange certificates, etc. So payment gateway is the first of all, the payment is done with the help of payment gateway and it verifies all certificates. It decrypts the authorization block envelope, digital envelope, which is to obtain the secret symmetric key and decrypt the block. Then merchant signatures are verified. Then this payment with block digital envelope will be done. Verify the digital signature and payment block, verify the received transaction ID, and finally the request and receive issuer authorization. So authorization responses are there. So authorization response message will be having these three things: the authorization related information, the capture token information, and the certificate. The SET overhead simple purchase transaction, 4 messages between the merchant and customer are there. 2 messages between the merchant and payment gateway will be there, and 6 digital signatures, 9 RSAs, 4 DES, then certificates, and finally the scaling is done for multiple servers need copies of all the certificates. So you can see that how we have talked about the SET. Before closing this lecture, I want to talk about this particular diagram. This is an important diagram. The first diagram has talked about the left hand side of this. On the left hand side, whatever transactions has been carried out, which is discussed over here, you can see over here, everything is done on the left hand side of this request message. PI is there, means payment information, which is attached with the dual signature, and this order information message digest. All these three things are combined together. You can see here, all these three things are combined together. They went here and encryption will take place with the help of the session key. This encryption will help with the help of the public key of B. Then these two things will go inside the request message. This is the first part, this is the second part. They are attached with the payment information message digest and order information. Dear signature and card hold certificates will be there. All these things all together comprises to a single request message. So you can see received by the merchant, and this particular portion is passed on by the merchant to the payment gateway. Now in the next part, I am zooming it in. You can see. Now in this diagram, we are going to talk about the right side part. Previously, in the previous diagram, we have talked about the left side part. Now we are going to talk about the right hand side. This request message information is there. Now this PIMD is concatenated. You can see this hash, that is order information message digest. These both things are concatenated, and finally hash is there. This payment order message digest is there. After the decryption of these two parts with the help of the public key of C, it is going to provide the payment order message digest, and both the values of POMD are compared with each other. If both these informations are calculated is the same, which is obtained from here, if it is same, then we can say everything is secure using this secure electronic transaction. So this is all about the secure electronic transactions. Thank you.